Visuino Component Creation Tutorial 01111010, or number 122 for all of you 10-base math users out there. And I just want to touch on one other fact. This version is in beta testing still. It is due to come out any day now. Today is the 19th of February, so yeah, I'd be looking for it pretty soon. You're going to be able to make your own stuff. Everyone knows that the first thing you do with your Arduino is you make the stupid LED blink. So yeah, this is the Blinky Blinky LED test. Let's do it. Welcome back, all you visual wieners. Let's go ahead and link the H files in the library up with the vcomp. Now this entails setting up a template. The only thing this template that is really important to know is all you're doing is setting up the pins in the sketch on the component to the properties box on the left. That's pretty much all you're doing, is just matching the two and naming them and setting the names to link with your H file. After you get it, it's really easy, and then you can stick it in different categories and stuff like that. But I will save that for a minute and let's get into it. Okay, so there is a file set that you can download that has these three files and the image file in it. All you have to do, it's called the testing library, and it has the test A files, which is what this video handles, is the test A. And then there's going to be a test B and a C and a D, and they're all going to link to like the unsigned and all that stuff. But in these text files is a README. Now there's a separate README for each of the videos also. And if you find it, it explains exactly what you have to do. But I'm going to go through it for you anyway, because I just feel like being nice. This is the template. This area right here. So, the two template areas right here, this is for input and output. Now those pins are right here on the actual test A component. Now you'll see over in the properties that the input does not have the ability to make a sync pin. There's nothing there, and I'm going to show you in a minute why. But that's a very, very super huge important thing to remember. Sync to sync or not to sync. I slay me sometimes. Wow. And getting back at the template here, over on the type name. Type name does nothing much more than set a name to the data value, like integer. That is just the name that you are going to refer to that data set from the properties and or the pins. That is all the type name is you are setting your name. Test A. Class test A. All it's doing is referring to this named component. That's all it is. Simple. Simple. It's naming them public so they can be accessed from the outside. In the T, the type name, input pin, output pin. Those are the two data sets that we're using in the C++ code of the H file. Now the template's done, and you have two type name data elements just kind of floating around, sitting in memory, waiting to be used by something, either a pin or a property or another setting or another component even. The V pin and V prop, that sets those two type name data elements to virtual pin and virtual property. Virtual pin and virtual property means that that data element is actually linked to either a pin or a property over in the component side, not in the code side. It'd be one of the sliders or a value you would put in or something like that. And then that is how it directly talks back and forth, is with those virtual pin and property settings. There's a lot more than just that. I don't know them all. I'm not even going to start right now. There. I got it. Okay, so now that anything with public access, it allows the outside access to be able to do something with it, to actually work with it. Now, if you set it to protected, you don't get a value entry bar. You don't get a sync pin. You don't get a slider. You don't get any of that. You just set yourself up a software interrupt. Yeah, you heard me right. A software interrupt just by setting it to protected. Protected means that only the change in the value can affect the outcome. On, off, on. Every time it changes state, it is a change of state interrupt, a software interrupt. Ta-da! That is simple. Okay, so now that you've got your software interrupt all set up, it is time for me to ask you for your support. You can like, comment, share, subscribe to the YouTube channel, or don't. It's all good. Or there's another way now. You can visit our Patreon, patreon.com/aka Pigeon Kicker. There's a project going on there right now, Hank the Hexapod. That is what I'm making these components for. I'm going to be developing inverse kinematics component and things like this that robots need. That is what I'm going to be making, are the components for the robots. If you want to help support it, support the effort, give us an attaboy or help support, get some new hardware for it for testing, or you want us to get something to add for you, or even make a custom component for you, we can do that. Just go ahead and check us out on patreon.com, aka Pigeon Kicker. The project is Hank the Hexapod. There's all kinds of videos about Hank for the last 3 years. I've been developing him. I've got all the 3D files made, and it is time to do the programming. And now with this new addition to Visuino, it can get done. Thank you, Boeing. That is a gift. And I gather you're tired of looking at my face right now, so let's get back to programming. Now, with this software interrupt that you got set up, you can use it in a lot of ways. There's a bunch of different ways you can use it. This is just a very basic, say, hey, here you go. It works. You can build on it. You can go to the other, vcomp files that are in the METOV libraries. There's a lot of source there you can use. Once the beta ends and you get the updated version, I can't wait for everyone to get that. If the input pin receives a state change, void, it runs a data set routine, and then that star, I think, is it stands for apply to program memory, or just short term, like a value that just that element can use or something. I'm not sure on that one either, but it sets it to underscore data. When it does this, you have that namespace. You just created a namespace, but only in memory usable by this part of the programming. Okay, you have to remember that, only this part. All right, now inside of this public inline void, you have a Boolean pin state. So what you're doing there is you're just creating another Boolean, yes, no, on, off, 0, 1, true, false, you know what I mean? And you're naming it pin state. So now you just made another type name in that namespace, only usable in that void, okay? And this pin state is gonna equal And then you've got that star sign here, see? That memory value, Boolean, yes, no. So it's the memory value is going to be either yes or no. And then that underscore data, that value that was stored in the short-term data set, the star, I think. I'm not 100% sure on that, okay? So what this does is when it gets when it runs this inline void, sets up a new Boolean every time, but it clears it out. Pin state, going to be yes or no, and it's going to equal the memory value of underscore data. All right, and then the next one, T output pin. The T output pin is the type name that you assigned to the actual output pin on the component, so you can wire it out. All right, T output pin, set pin value. So you're with set pin value, you are changing what is stored in the T output pin value, and you are setting it to pin state. And that is right where we just set it, right there with the Boolean. T output pin, the type name from this namespace is going to be set to the pin value of whatever that pin state is, yes, no. And then for the rest, you know, don't forget your punctuation marks. And yeah, that's pretty much it for the H file. It's kind of simple, huh? I mean, honestly, that's literally it. It's an automatic. If it changes, it's going to change it on the out. It's a pass-through. Yes, no. Tick, 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 tick. So, go ahead and save it, and let's go to the next part. All right, now for the vcomp file, that is the testing underscore test a.vcomp file. The first line is testing. That is setting it to the namespace of testing. So any component that is created under that namespace can use other pieces of other components with that same namespace. Okay. And then in 3, Arduino include testing underscore test A. That is actually linking it to the testing underscore test a.h file in the libraries folder. Okay. The next one, Arduino class. Testing, that is the namespace. We are setting the namespace of testing to test A. The class is test A. That is right there. Okay. That is what you're setting the template for this particular namespace part. All right. Create name. Now that is what the what Visuino is actually going to put right here on the box. All right, right there. So you can't use spaces, underscores, no funky wording or anything like that. Keep it simple, stupid. You know, one of those things. This one's named Test A, and every one you put on from there, it's going to be Test A1, Test A2, Test A3, and you can still rename them. And then que sera, moving on. Name Test A. Now where the name is only where it's going to name it in the properties box. It has, you can name it, you can put spaces in it, you know. You want to try and keep it kind of the same so you don't get yourself all friggin' confused. Okay? So don't get too crazy with it. And now in line 7, the category, we're adding it to the toolbar in the digital toolbar character. So if you look here, this is right in the digital box. All right, open that up, scroll down a little bit, and it is right there. Test A. See? All right, there. Nice little test underscore A icon. I made that. All right, and then after that, the plus right there, Arduino test A. The plus sign adds the icon to the toolbar. If you keep the plus sign off, it's hidden, it's invisible. You won't be able to select it and drag it into your sketch. That's what the plus sign does. If you don't add the plus sign, that means that this particular namespace and class would be usable by another component in the same namespace. Okay, that is how you make multiple linkings between components. So you have, let's say you've got inverse kinematics 3 with 3 portions to the leg, inverse kinematics with 4 portions to the leg. You can make different sections and different types of the different components, and you know right where those are. That would be the little tool wrench right there that's in the corner. That is where you set those for the type. You can have different, many different kinds. And then again, the Arduino common Boolean flexible filter, that is what the base template of the actual component is, with the input pin and the output pin. The common Boolean flexible filter is actually one of the Delphi files that's in Visuino. You won't be able to find that. It's not out there. It's one of the NDA files, but it's one of the base starting points to build. And there's a lot. There's common Boolean, there's common singles, which is a different one. There's common analog, all kinds of stuff. All kinds of stuff you can use it for. Flexible filter means you can do something with it. It's changeable, okay? There's different ways you can adapt it. And the filter means you're going to have an output, I think. Filter, I mean, I think the filter adds an output pin. You know what I mean. So, and again, remember your punctuation. And let's go ahead and save this file, because that is all that you have to do. You're done. You are literally done. When you start it up, you're going to see Visuino there, and you're going to see your new component, and you're going to be able to add it, and you're going to be able to change it and build on it, and well, there you go. And if you got everything done correctly, you have a board with a blinking light and everything is working. And you can also see it changing true to false down in the bottom here, and it is reading. So everything is working as planned. So remember, like, share, comment, subscribe, or don't, it's all good. And please try to visit the patreon.com/aka Pigeon Kicker and help us along with the projects. Our next project is Cutesy1, and he is another robot I've been developing for a couple years. He had an accident. Yeah.
This is, oh, I got a fire going on here with him. Let me turn him off. Uh-oh. Oh. That sucks.
And if that wasn't bad enough, then this happened.
Wow, what was that? He blew up.
So yeah, he he blew his friggin' lid, dude. Boom! Pieces everywhere, wires sticking out, smoking on one side. I still got the other body. He threw his face across the living room on the other side. Clear across the friggin', wow. Yeah, but he's better now. He's made out of carbon fiber. He's got 3 inches of suspension travel on it, and he is a cool balancing robot, and he's next. Thank you for watching.